So, what's really going on inside an AI's head? I mean, what is it actually thinking? It's got to be one of the biggest questions in all of tech, right? Well, today we're going to try and crack that open. We're diving deep into what's known as the black box of artificial intelligence to see if we can finally get a glimpse of the logic behind its decisions. And really, it all comes down to this one simple question. I mean, can you really trust a decision if you have no clue how it was made? Think about it. If an AI is diagnosing a disease, or deciding on your loan, or even driving a car, how can we put our faith in that if we can't understand why it did what it did? It's tough because, without that understanding, trust is, well, it's pretty much impossible. This is the whole problem, right? So many of today's most powerful AIs are basically becoming these black boxes. We can see what we put in, the data, the questions, and we see what comes out, the answer. But that whole middle part, the billions of calculations, the stuff that makes up its reasoning, it's a total mystery. And that black box, well, it's a huge problem. It gets in the way of fixing bugs, making sure these things are safe, and building our trust in them. Okay, so here's the kicker. You'd think with all the progress we're making, this problem would be getting easier to solve. But it's actually getting worse. Researchers have a name for it. They call it the complexity challenge. And it makes sense when you think about it. Just a few years back, a cutting-edge AI had maybe one job. Its whole world was, say, telling you if a picture had a cat in it. Super simple input, super simple output. But today's AIs? Whoa, they're a completely different beast. We're talking about a self-driving car, juggling video feeds, map data, and a dozen sensors, all at the same time, while making split-second life-or-death decisions. The old, simple tools we had for looking under the hood, they just can't handle that level of chaos. And hey, it's not just me saying this. The people building these things are saying it too. A recent research paper, the one that inspired this whole explainer, put it really bluntly. They said our existing frameworks often lack support for composed models with multiple inputs or outputs. Basically, there's this huge gap between the AIs we're building and the tools we have to understand them. They just weren't built for this new world. So, if our old set of keys doesn't work on these crazy new locks, what do? Well, you build a new key, right? Or better yet, you build a new kind of universal toolkit, one that's designed from the ground up for modern AI. And that's where something called TDHook comes in. Let me introduce you. Think of it as that universal key we were just talking about. It's a new, open-source tool that's built to plug right into pretty much any modern AI model made with PyTorch. And by the way, that's one of the biggest platforms out there for building this stuff. The whole point of TDHook is to give us that peek inside, no matter how complicated the AI gets. So what's so special about it? What makes TDHook different? Well, for starters, it's universal. It just plugs in. It's also super lightweight and really fast, which is a huge deal when you're running massive computations. But honestly, its secret sauce is that it's tensordict powered. Now that sounds super technical, but all it really means is that it was born to handle the exact kind of messy, complicated, multi-part data that makes all the older tools just fall over. And when I say lightweight, I'm not kidding. Look at this. TDHook only adds about 18% to the memory footprint. Now, compare that to some of the other popular tools out there. They can more than double it. That is a huge difference, especially when you're working with massive models where every bit of memory counts. Right, so it's not just smaller, it's also way faster. The benchmarks show it can be up to 2 times faster than Captum, another big framework when you're looking at exactly these kinds of complex models. So you're getting the whole package here. Smaller footprint, faster performance. It's a win-win. All right, enough with the theory and the numbers. That's all great, but what does this actually look like in the real world? Let's see TDHook in action. So let's ask a really cool question. Have you ever wondered what a superhuman chess AI actually sees when it looks at a chessboard? I mean, where is its attention focused? What does it think is important? Well, to figure that out, we can use TDHook to create something called a saliency map. The easiest way to think about it is like putting on a pair of heat vision goggles that show you the AI's attention. It creates this heat map right on top of the board, showing us exactly which pieces and squares the AI is zeroing in on. The brighter and hotter the color, the more important the AI thinks that spot is. Okay, but here's where things get really interesting, and where those older tools would just break. This particular chess AI isn't just doing one thing, it's multitasking. It's trying to find the absolute best next move, and at the same time, it's calculating its overall chance of winning the entire game. So that's 2 different jobs, 2 different outputs, basically 2 different thoughts happening at once. And this this is the incredible part. This is where the magic happens. Because TDHook can handle those two separate outputs, we can generate a unique attention map for each thought. Just look at this. On the left, when the AI is thinking, what's my best next move? Its focus is laser sharp. It's all about the immediate threat from that attacking rook and bishop. But now look at the right. When it asks itself, what are my odds of winning this whole game? Its focus changes. It still sees that immediate threat, sure, but it also lights up the opponent's queen, seeing it as a critical piece for the long-term strategy. This is amazing. We are literally seeing two different streams of consciousness, two different ways of thinking about the exact same board at the exact same time.
Okay, seeing an AI think about a chess game is really, really cool. I mean, it's fascinating. But let's bring it back to the real world. So what? Why does this actually matter? Why is it so important to turn that black box into a glass box?
Well, it really comes down to three huge things. First off, debugging. If an AI messes up, we don't have to just shrug our shoulders anymore. We can go inside and see exactly where its logic went off the rails and then fix it. Second, safety. This is a big one. We can check these models for weird biases or potentially dangerous patterns before we let them loose in the world. And third, and maybe most important, trust. I mean, for really critical areas like medicine or finance or self-driving cars, this gives us a way to actually verify that the AI is making good, sound decisions. We can finally start to deploy them with real confidence. Because at the end of the day, that's the whole point, isn't it? This idea of interpretability, of being able to understand the AI, it's not just some nerdy academic puzzle. It is the absolute key to making these systems more reliable, much safer, and ultimately something we can actually trust as they get woven into the fabric of our lives. And that leaves us with a pretty wild thought to chew on. As tools like this give us a clearer and clearer window into the mind of an AI, the question starts to change. It's not so much if we can understand how it thinks anymore, but rather, what's the very first thing we should ask it? What would you ask?